Good morning, it's Tuesday the 9th of June. I gave you 4 questions to do on sketching curves. I'll now go through all of those questions one at a time because they're very important questions. Okay, so question number 1. Sketch y is equal to 4x to the power of 3 plus 6x squared. So 2 things first of all we need to do is where it cuts the x-axis and where it cuts the y-axis. So it cuts the y-axis when x equals 0. So therefore y is equal to 4 times 0 to the power of 3 plus 6 times 0 squared. That's obviously 0, that's 0, so it's cutting at the point 0, 0, so it's cutting at the origin. Now, that means that we're going to get a 0, 0 point down here as well. Okay, so you always look out for wee things like that and it helps as you're doing them. Right, so we want to find out where it cuts the x-axis. So it cuts the x-axis when y is equal to 0. So 0 is equal to that whole thing there. I'm going to read it round the other way. So 4x to the power of 3 plus 6x squared equals 0. Now, factorise, highest common factor, 2x squared. When I take out a common factor of 2x squared, I'm left with 2x plus 3, and that's all equal to 0. So 2 things that multiply together to give me 0, so either one of them could be 0, so 2x squared could be equal to 0, or 2x plus 3 could be equal to 0. So that's giving me 2 points. It's given me the point where x equals 0, because divide by 2 it's still 0, square root of 0 is 0. There, 2x plus 3 equals 0. Take 3 away from both sides, so 2x is minus 3. Divide by 2, so x is equal to minus 3 over 2. Right, so therefore it's cutting at 0, 0, as we expected, same as that one. And it's cutting at the point minus 3 over 2, 0. Right, so next thing I've got to do is I've got to find out where the stationary points are. Okay, so I've got stationary points occurring when dy by dx is equal to 0. So dy by dx for this one here, multiply by the power, take 1 away from the power, and you should have dy by dx is equal to 12x squared plus 12x. Now we know that's got to be equal to 0. So therefore 12x squared plus 12x equals 0. Factorise, common factor, 12x. That leaves me x plus 1 equal to 0. So I've got a stationary point when 12x equals 0. Divide by 12, x is equal to 0. And I've got another stationary point where x plus 1 equals 0. Take 1 away from both sides, so x is equal to minus 1. So I've got 2 stationary points at 0 something, and the other one is at minus 1 something. Now we've already worked out the point 0 something. That is the point 0, 0. The y coordinate is 0. Go back and check it if you wish. This one here, we want to work out the y coordinate. Now I know the y coordinate is equal to 4 times x cubed, so it's 4 times minus 1 to the power of 3 plus 6 times minus 1 squared. Okay, when I work that out, that is minus 1. 4 times minus 1 is minus 4. That gives us plus 1, 6 times 1 is 6. So that is 6, take away 4, and that is the point 2. Okay, so I've got the coordinates of my 2 stationary points. Next thing I want to do is I want to find the nature of those 2 stationary points. So draw your table for the nature. Okay, so we have got the x values at the top. There's 2 stationary points. I'm going to split it into 2 sections. And top section, I want to know what's happening in the x numbers. Stationary points, put them in order. So the minus 1 is more to the left. That's the smallest x number. And then the 0, 1 will go there. I want to know what's happening before that. Is it sloping uphill, downhill, whatever. And the same with those ones. Okay, now dy by dx for each of these. We're going to use, we've already worked it out, and I'll write it in there just to remind us. So dy by dx was 12x squared plus 12x. Okay, right, now I need a value less than minus 1. So a value less than minus 1 will make minus 2. Now I need a value between minus 1 and 0. Unfortunately, we're forced into using minus a half. Okay, you could use minus 0.8, whatever, as long as it lies between them, but that's the most sensible one. Right, now we look for a value now greater than 0, and the obvious one there, and the easiest one is 1. Right, so what we're going to do is we're going to substitute minus 2 into that. So minus 2 squared is 4. 4 12s are 48. So that's 48. And I'm doing 12 times minus 2 is minus 24. So 48 minus 24 is going to be positive. Stationary point is 0. Stationary point in there, I'll put in 0 while I'm doing it. Now, x equal to minus a half. I'll write this one out because it's not as easy to do in your head. So it's 12 times minus a half squared plus 12 times minus a half. So when I do that, I get minus a half squared is 1 squared and 2 squared, or minus 1 squared and 2 squared, which is 1 over 4, and it's positive. So it's a quarter of 12, which is 3. That gives me minus a half times 12. Half of 12 is 6, so that's going to be minus 6. So therefore that makes it negative. That's the same. Now I want to do the same when x is equal to 1. Okay, right, I'll just write it down again. So dy by dx when x is equal to 1 is 12 times 1 squared plus 12 times 1. That's going to be 12 plus 12 is 24, so it's positive. So I've got a curve that slopes uphill, then across, then downhill across and uphill. So I've got a maximum turning point, and that's sitting at the point minus 1, and the y coordinate at that point was 2, and another stationary point which is a minimum turning point, and that's sitting at the origin 0, 0. Right, so I now know where it crosses the axis, and I know my turning point, so now we have to sketch it. So draw your x and y axes. Excuse me. Okay, so this one was crossing at the point 0 at the origin, so it was crossing there, and it was crossing at the point minus 3 over 2, or minus 1.5, so it's crossing the x-axis there. Right, now I know that there's a wee maximum turning point sitting here at the point minus 1, 2, and I know there was a minimum turning point sitting at the origin. So all I have to now do is to draw a nice smooth curve through them. Okay, so it's going through that point there, it's coming up, it's turning, maximum turning point, and then it's coming down, and it's got a minimum turning point, and it's doing that. Okay, second one I gave you to do was y is equal to 3x to the power of 5 minus 5x to the power of 3. So again, cuts the y-axis when x equals 0. So y is equal to 3 times 0 to the power of 5 minus 5 times 0 to the power of 3, which again is 0. So it's crossing at the origin. Right, where it cuts the x-axis, that's always the harder one because it cuts in more than one point. So we're going to make y equal to 0. Now I know y was equal to 3x to the 5 minus 5x to the power of 3. So 3x to the power of 5 minus 5x to the power of 3. That was y equals, but we know y is 0. We'll put the 0 in at the end. Right, so again, we factorise this. Okay, so when we factorise this, we're looking for the highest common factor. And I can see x to the power of 3. So that will give you 3x squared minus 5, and that's equal to 0. So from this point here, we've either got x equal to, or x cubed first of all equal to 0, cubed out of 0 is still 0, so x is 0. This one here, we've got 3x squared minus 5 equals 0. So add 5 onto both sides, so 3x squared is equal to 5, divide by 3, so x squared is equal to 5 over 3. Now I want to take the square root of that. You always have two values, okay, except for when it's equal to 0. So therefore x is equal to the square root of 5 over 3, or x is equal to minus the square root of 5 over 3. Now it's really important you get used to that, because if you miss a turning point, nothing will work. It'll all be a mess in the middle, okay, or you miss a point where you're supposed to have solved that. Okay, so next part, stationary points of curve and dy by dx is equal to 0. So therefore, dy by dx is 15x to the power of 4 minus 15x squared. So that whole thing is equal to 0. So 15x to the power of 4 minus 15x squared equals 0. Keyword is factorise. Highest common factor is 15x squared, which gives me x squared minus 1. Okay, so either 15x squared equals 0, so that means x squared is 0 divided by 15, which is still 0. Square root of 0 is 0, so x is equal to 0. X squared minus 1 equals 0, add 1 onto both sides, so x squared is equal to 1. You're taking the square root, so square root of 1 is 1, but also remember the negative root, x is equal to minus 1. So in this case, we've got 3 stationary points. We've got a stationary point at 0 something, a stationary point at 1 something, and a stationary point at minus 1 something. Now, when you substitute in your values, well, you already know that the point 0, 0 lies in this curve, so we can put that in. When you substitute 1 into y equals, you get minus 2. And when you substitute minus 1 into it, you get y is equal to 2. Okay, and I'm not going through the working of that. You just do it in a calculator. Right, so 3 stationary points, we need to know what the nature is. So nature, split your table into 3 sections this time, because we've got 3 stationary points. So there's 1, 2 and 3. Now take your stationary points, smallest x value first, so it's minus 1 in here. The next one is at 0, and the next one is at plus 1. I want to know what's happening before, what's happening after, before, before, and after. That's all the x values. So the next thing I want is the y by dx. And the y by dx, look back and see what that is. 15x to the power of 4 minus 15x squared. Right, choose values. It's a value less than minus 1. We will choose minus 2. A value that's got to go between minus 1 and 0 has got to be minus a half. And that'll be the same in there. A value between 0 and 1, we're going to be forced into using a fraction again, so that's a half. A value bigger than 1, we'll use 2. Right, so when you put minus 2 into that expression, you get 2 to the power of 4. 2 2s are 4, 4 2s are 8, 2 8s are 16, so you get 15 times 16, and you want to take away 15 times 4, so that's obviously going to be positive. Stationary point we know is 0. When x is equal to minus a half, so a half to the power of 4, and it's going to be a positive because that's an even pair, so you're multiplying 2 pairs of negative numbers, so it's always going to be positive. Right, so that's going to be 2 2s are 4, 4 2s are 8, 2 8s are 16. So that is going to be 15 times 1 over 16. And that's going to be minus 15 times minus a half squared is a quarter. So that there is smaller than that. So therefore it's going to be negative. When x is a half, that's going to be, again, 1 over 16. And that's going to be minus 1 over 16, so that's again going to be negative. That's the same, stationary point at 0. And when x is 2, 2 to the power of 4 is 2, 4, 8, 16, 15 times 16, minus 15 times 4. So it's got to be positive as the second number smaller. Right, so we've got positive sloping uphill, going across is negative, then we're going downhill, downhill across, and downhill again, downhill across, and then uphill. Right, so we're getting a point of inflection in this one in the middle. Right, so we've got a maximum turning point, and that maximum turning point was at the point minus 1, 2. Then we've got a point of inflection, a PI, and that's at the point 0, 0. And then I've got a minimum turning point. And that minimum turning point was at the point where we had 1 minus 2. Right, we need to sketch all of that and put all of that together. Right, so axes, y-axis, x-axis. Okay, label your axes, x and y. Now I'm going to look and see where it cut the axes. So it cut the y-axis at 0, 0, so we dot in there at the origin. And it cut the x-axis at minus the square root of 5 over 3 and plus the square root of 5 over 3. Okay, then we had 2 turning points at minus 1, 2. So at minus 1, 2, so minus 1, 2 is about there. And we're going to label that as minus 1, 2. And that stationary point was a maximum, so a maximum there. Then we had a point of inflection here, so it was coming down, going across and back down. And then at the point 1 minus 2, which is down here somewhere, so that's 1 minus 2, we've got a minimum turning point. Right, stick all of that together. So I'll draw it in black. It goes through the x-axis, it comes up and it turns, then it comes down to the point of inflection. So it's curving there, curving down there, then it comes down and it does the minimum turning point, and then it comes up, oops, and it crosses, and I'm going to change that point there as root 5/3. Okay, it's easier for you to draw this in paper than me. Right, so that is a point of inflection, so it's going down and it's curving. So that's not just a straight, that's curving. Okay, so that should curve like that, and it should curve like that. It's like half of parabolas. Okay, so please make sure yours is a bit neater than mine. Okay, number 3, so we want to sketch y is equal to x to the power of 6 minus 6x to the power of 4. So again, cuts the y-axis when x equals 0, so y is equal to 0 to the power of 6 minus 6 times 0 to the power of 4. All of that is 0, so it's cutting at the origin. Right, next one then is where it cuts the x-axis, so it cuts when y is equal to 0. So y is equal to 0, so 0 is equal to x to the power of 6 minus 6x to the power of 4. I've written this with the numbers at the end. I want to take out the highest common factor there, so the highest common factor is x to the power of 4. That gives me x squared minus 6, and that's equal to 0. Right, so either x to the power of 4 equals 0, so the fourth root of 0 is still 0, so x equals 0, or x squared minus 6 equals 0, and that gives us x squared equal to 6, so x is equal to square root of 6, but don't forget x is also equal to minus the square root of 6. Right, so the points where it cuts the x-axis are 0, 0, minus root 6, 0, and root 6, 0. Okay, next bit, stationary points. So where do stationary points occur? So stationary points occur when dy by dx is equal to 0. So stationary points when dy by dx is equal to 0. Okay, you will have taken your derivative, so multiply by the power, take 1 away from the power. So dy by dx is equal to, it's going to be 6x to the power of 5 minus 24x to the power of 3. So that's equal to 0. Right, so highest common factor is going to be 6x to the power of 3. So that then gives me in the bracket x squared minus 4. So 6x to the power of 3 equals 0, or x squared minus 4 equals 0. So divide by 6, nothing divided by 6 is still nothing, the cubed root of nothing is still nothing, so x is equal to 0. Then we've got x squared, add 4 onto both sides is 4. Take the square root, so x is equal to 2, but don't forget x is equal to minus 2. Right, so for this one we've got 3 stationary points, so I'm going to put them in order this time. So I've got minus 2 something, I've got 0 something, and I've got 2 something. Right, so go back up to your y coordinate, and we've got minus 2 to the power of 6, minus 6 times minus 2 to the power of 4. Right, so you can use your calculator for that, and it turns out to be minus 32. Now I know that the point 0, 0 lies on it, and now I'm going to substitute in 2, so it's 6 times 2 to the power of 6 minus 6 times 2 to the power of 4. Now because the powers are even, then it makes no odds whether that's minus or whether it's positive. It turns out to be the same, so it's minus 32, but put it in your calculator and you can see that. Right, so I've got my stationary points, I've got all the other important points, so it's now to get the nature. So the nature table, I've got 3 turning points, so split this into 3, 1, 2, 3. X values, we're going towards minus 2, I'm going away from it, then I'm going towards 0, I'm going away from it, I'm going towards 2, and then I'm going away from it. And in this case, the y by dx, I'll fill that in here. So the y by dx is equal to 6x to the power of 5 minus 24x to the power of 3. Right, now I already know stationary points at 0, so I'll put them in because there's 3 of them, it's quite a lot there. I want to pick a value less than minus 2, so I'll pick minus 3. A value between minus 2 and 0, minus 1. A value between 0 and 2, so 1. And a value bigger than 2, we'll pick 3. Right, so we've got minus 3 to the power of 5 times by 6. And that's minus 24 times minus 3 to the power of 3. Right, stick it all into your calculator. The answer is negative. Then I've got minus 1. I've got 6 times minus 1 to the power of 5, which is minus 6. Minus 1 to the power of 3 is also minus 1, so it's minus 6 minus 1, so that makes it plus. So it's going to be minus 6 plus 24, which is going to be positive. That's positive. When x is 1, that's going to be 6 minus 24 is negative. That's negative. When x is 3, 6 times 3 to the power of 5 minus 24 times 3 to the power of 3. Put it into your calculator and it turns out to be positive. So we've got downhill across uphill, uphill across downhill, downhill across and uphill. So minimum turning point at the point minus 2 minus 32, a maximum at the point 0, 0, and we have got another minimum at the point 2 minus 32. Okay, put all of that together. Okay, so points where it crosses the axes. Right, so that's the x-axis, that's the y-axis. Okay, so I've drawn down the axes. X and y-axis is crossing the x-axis at minus root 6, 0 and root 6. It's got a maximum turning point at the origin, and it's got 2 minimum turning points at those 2 points there. So you've got all of the different important parts annotated. Now draw a smooth curve between them. Okay, so that's it. It comes down there. There's a minimum turning point, and it goes to a maximum turning point. It comes down to another minimum point, and that's your crossing the x-axis. Okay, so just check the diagram. Okay, last question. Y is equal to 6x to the power of 4 minus 6x to the power of 6. Okay, so same thing. Cut to y-axis when x equals 0. So y is equal to 6 times 0 to the power of 4 minus 0 to the power of 6, which is equal to 0. So it's crossing the point 0, 0. Right, next one cuts the x-axis when y is equal to 0. So therefore, in this case, we've got 6x to the power of 4 minus x to the power of 6 is equal to 0, because y was equal to that. Right, so highest common factor, x to the power of 4, and that gives me 6 minus x squared in the bracket. So therefore, so x to the power of 4 equals 0. The fourth root of 0 is still 0. 6 minus x squared equals 0. Add x squared onto both sides. So you've got 6 is equal to x squared. To undo that square, take the square root. So x is equal to root 6. And don't forget, x is equal to minus root 6. Right, so it's cutting at 3 points. It's cutting at 0, 0. It's cutting at root 6, 0. And it's cutting at minus root 6 and 0. Okay, stationary points, the next one. So stationary points when dy by dx is equal to 0. Now, the number of times you've done this and repeated it and written it down, you should now have this clear in your head of all the stages you go through. Right, so multiply by the power, take 1 away from the power, so dy by dx is equal to 24x to the power of 3 minus 6x to the power of 5. Now that's equal to 0. Key word to solve that is to factorise. So we'll take out our highest common factor, which is 6x to the power of 3. That gives me 4 minus x squared, and that's equal to 0. So 6x to the power of 3 equals 0, divide by 6, x to the power of 3 is 0, the cubed root of 0 is still 0. Add x squared onto both sides because 4 minus x squared equals 0. So 4 is equal to x squared, so x squared equals 4. So the square root of 4 is 2, so x is 2, or the negative root, minus 2. So our stationary points at the point 0 something, 2 something, and minus 2 something. Right, go back to your y coordinate and find out what y is equal to. I know the point 0, 0 is on this curve, so that's 0. Right, substitute 2 in, and you get an answer of 32 when you substitute in y. Do the same here, you also get 32. So now we're going to sketch that curve. Okay, so I've put all points in, draw your nice curve through them all. Okay, now that was quite a lot of work there just now. Right, so what I want you to do is, I want you just to go back over them, and what I'm going to ask you to do is I'm going to ask you just to revise everything that we have done so far. Now, Mr. McCutcheon has been putting on some revision questions for you. Follow his revision sheets just now, okay? So that's the end of new work. We're just going to revise all of the stuff you've done because you've done about, what, 9 weeks of new things. So it gives you a wee chance to consolidate all of that and get it all clear in your head for starting school.